Welcome to the screencast. In this screencast I would like to talk about what I would have talked about in the hands-on 3 session. Unfortunately I got sick, so I can't be there for the lecture, but I hope that you can self-study using the screencast. The plan is then that there is a learner forum where you can ask questions with regard to the screencast. If there's great demand, we can have a question and answer session next week. What are we going to do in the screencast? I would like to talk about hands-on 3. And hands-on 3 is going to be OpenStreetMap Painting. And the idea is that we take our program from last week and enable or make it possible to draw OpenStreetMaps data. So what we want to do is we want to write a model view control-based program that is able to read and display an OSM file. And this OSM file, as one OSM file, is given here to you. But in the very beginning I would actually talk about something else that is going to be very useful for you throughout your whole project time, and that is one part from hands-on 2, saving the state of the program, including any edit lines. So let's go back to hands-on 2. Let's work a little bit on that. So first of all, I'm going to work on hands-on 2, but let's do it in hands-on 3 directory. I'm going to edit files only there. Now let's open this in IntelliJ. So it's hands-on 3. I'm going to import this anew. And now just to run through it, what did we do last week? Well, we did a model view controlled based line drawing application. So we were able to draw lines. The drawing part was in this canvas here, where down here we just drew lines, but we had to do a lot of other things. So we used anti-aliasing to make it look a bit nicer. And the main part was telling you about these affine transforms that enabled us to both pan our window and to zoom in and zoom out. And that was the part in here where we had to pre-concatenate our current transform with a new affine transform. And this could be a translate instance for panning or a scale instance for zooming. Yeah, and what we talked about was handling mouse input using the mouse adapter and key input using the key adapter. And if you have questions with regard to that, I suggest that you go back to the screencast for hands-on 2 and look at that one more time. Okay, let's talk a little bit about saving the state of the program. So what we want to do is, if we just start up our main method, didn't provide a command line, a file on the command line, so it's just going to be empty, but we added this drawing mode where we could easily draw some lines. What I want to do is I want to save and load these lines. Now where did we load files? That was here, this read from file. And now there are two options. The first option is that we're going to build a read to file, a write to file method here that just does the opposite thing. So it takes a line and generates a string and writes it to a file. But this is very targeted to this line drawing, and I actually want to show you something different, something that is more generally applicable, and that is writing and reading Java objects, so something that is native to Java. Let's have a look at this. How do we do this? So what I want to do is I want to save and load data in this model, and what is the data? It's this list of lines. So let's write two methods here, public void save string file name and public load string file name. Okay, let's first talk about saving. So what I want to do is I want to save this list of lines. How can I save this list of lines? I can use the object output stream. generate a stream of objects. Let's call this OS object output stream. Where do I want to what do I want to do with the stream? I want to write it to a file. File name is file. Of course, this could fail, so we have to surround it with try and catch. And it's an all exception that could of course happen. And now all I need to do is I have to call write object. Write object with the object that I want to write, and that's just lines. That's the whole save method. If I want to load, well, let's say, I mean, we should still support we could still support this format up here. So if somebody provides a file that ends with a file name that ends with .txt, we could say, well, this then we should read from the file. But if somebody provides a binary file, let's say we call it .bin for binary, then we actually want to reverse this step here. So what we want to use is we want to use an object input stream. Let's call this is new object input stream. We want to read from a file input stream. File. Of course, again, this could fail. So we have to add this IO exception here. Or we can let IntelliJ do this work for us. What is more, now we have to read the object. So we can use this read object. And this will read the first object. But now there's only one object that we stored. So this is going to be the object that we are interested in. And what we want to do is, this should be lines. Of course, read object, if a lot of things could happen. For example, the object that is read is a class that we actually do not have in our program, because we read, for example, a file that was created from a different program. So this is the class not found exception. Now in general, as you see down here, the read object just returns an object, but we require a list of line to D. So we have to cast this, and this is of course not very nice, but this is the only way we can do this. Okay, no, list. Okay, after we have loaded the file, we of course have to tell the model that something has changed, and we do this by calling the dirty method, which then sets a change and notifies all the observers. To use this, it would of course be nice to have a menu bar up here, but this is something that you could you can do on your own. So let's just use the keyboard for loading and saving. We see all of our, let's go to the keyboard controller, we see that L and S are already taken, so we have to come up with some new shortcuts. Let's say O is for loading, so here we call model.load, and let's say just expect that there is a file called output.bin, and if the user presses P, but next to it, then that's our save output.binary. Let's give this another run. So let's go into drawing mode. Let's draw some lines. Let's now press P to save the model. Okay, down here you saw that I pressed P. Now there should be a file, and there it is, output.binary. And we see this file makes little sense to us. But it says it's that it's an array list of line 2D objects, and then there's x1, x2, y1, y2, but all of this is not readable because it's just a binary representation of the object. So this should have worked. Of course, it would be nicer to give a message, that we saved something, but that's something that you can do. I'm just adding some lines to this very beautiful drawing. And now I'm pressing, what was the button? What was the key? I'm pressing O to load our old model. And we see we're now back again to this initial drawing. Perfect. So that's how you can easily load and save the model. If you're interested in performance, you should figure out like what is faster. Is this part faster, reading from a file, or is this part faster? The answer might surprise you. Now we have a save and load. There's also something up here. So we say that the model implements serializable. That just means that we tell the user, well, a model here can be stored and saved to some format. In particular here it's actually a native object format to Java. This will become very handy in the end for your project because you can easily store and load any kind of input and any kind of data. Okay, and that's the first part that I wanted to show you. Of course, it's also a nice exercise for you to work on a saving method that would actually save into our data format. It was presented up here. Okay, that's the first part that I want to talk about. Now, let's go back to what we want to do when we draw OSM files. So first of all, I'm going to take this Openstreetmap files that I provided here to you and save it into our data folder, small.osm. And let's look into this data folder. And let's say we remove all of these other files here. We are not going to need those files once we have support for OpenStreetMaps. Also, what we are not going to need for now is this lines format. So that's something that we don't need for hands-on 3 anymore, because now we actually want to read OpenStreetMaps data. We don't want to read this file format. So let's also get rid of that. Okay, but still, let's say what we want to do is we want to use OpenStreetMaps data. So read from file here is read from OSM, and let's change that to read from OSM. Okay, let's go to Git and commit some changes. Okay, this read from file here should actually now be load, whatever the file name is. Okay, let's have a look at and add something to Git. So we want to add this. I want to add this data folder. Git add data, and I want to add our current source files. Okay, let's say the commit message should be started working on hands-on 3, edit, saving, loading objects. Let's push this to GitHub. Perfect. Let's look at this OpenStreetMap file format. There are always two things we should take into account. This is the actual OSM file. So this is XML. You heard a lot about XML, but also you should ask yourself, and this file is a bit old, and I'm going to provide you newer files as well, but you should always ask yourself, like, where does this file come from? And it comes from actual OpenStreetMaps data. So you can go to OpenStreetMaps, and I'm already here in Copenhagen, and you can actually look at the data here as well. And that is something that you do by you zoom in far quite a lot, and then there's this button here to the right, query features. You can press it. For example, you can ask, like, what is around here, And it will tell you to the left, well, here are a lot of nodes. There's a building called Mikado House. There's a residential road called Langoswei. And there are some enclosing features, so it's on the island of Amma, it's in the country of Denmark, and so on. And also there are these nodes here. A node, let's have a look at that. A node has some information. For example, it has information about the address, which will become very handy for your project. And it also knows about the location. So the location is a certain latitude, longitude coordinate. And I provided some links on Learn It, but you can also go through this one here one more time. So we use the geographic coordinate system, and that is latitude is basically the y coordinate here, longitude, that's the x coordinate, or it's going to be the x coordinate for our purposes. Okay, and you can read this up a little bit. We'll have some issues with that in some minutes. Okay, so let's go back. So there's OpenStreetMaps. A node is the most basic information. And if we go back, for example, and ask what was Langoswei, it's a residential road, and you see this is called a way, and the way connects or consists of nodes. So these nodes here, they define the way. And you get a lot of more information here as well. So the highway is residential. So the highway says it's a street. The type of street is a residential street. Okay, and so on. And this is all reflected in the OSM file as well. And let's go. So our file is a bit smaller that I've provided to you. So we have this, for example, Torgale. Let's just look for this. Torgale. There it is. And what we see here, this is part of a node. So this node is in the street Torgale. And at some point we should also find a way. So let's see. And all of these nodes, those nodes, you can also see them here. Okay, let's go down a little bit because I think all of those so this is a way ID, with name Torgale, but this consists only of 2 nodes, and this is a highway, a tertiary highway. I think this is not Torgale that we are interested in. It's not that one as well. I think it's not that one as well. It could be this one. This one consists of quite a lot of nodes. Okay, but you get a lot of information, so the important part is that the way consists of these nodes, as we can, for example, see it when we go to our street. Where's our street? There it is. And it's these little parts. Right? And you see the nodes it consists of here. Okay, you should always have that in mind, that there's always this connection between what you see here, and you can actually query for these features. And those features are represented in XML by certain tags. And there are nodes, and there are ways, there are other things that we have to talk about. So now you've learned about reading XML files. So let's have a look at this. We want to use a sex parser because it's much more performant, and it needs we need to define an event handler, and we have to read. We have to create an XML reader. like you've seen in class. So let's do this. So first of all, we go to our model. Now we want to have this read from OSM file, and read from OSM file. How it works is we use an XML reader. Let's call this XML reader equals new XML reader, and this was actually created by Refactoring. Okay, like this. A few things could go wrong. So there could be an exception. This thrown, and we can surround it with try and catch. For the XML reader, we have to set a content handler, and let's say this is a OSM handler. It's something that we have to create, and then we can say XML reader.parse and just provide defining. Okay, and of course, parsing a file, that could lead to some I/O exceptions. Like this. Now the content handler, that's a OSM handler. Of course, we have to create this one, and I want to create this one as an inner class because it's only used from within the model, and it will set some variables of the model as well. So I want to create this inner class called OSM handler. Okay. This could now implement the content handler in general, and it's a little bit like implementing a key listener versus extending the key adapter, which contains a lot of empty implementations. If I were to implement the content handler, let's just look at what would happen. It would say, you have to implement all of these methods. I don't know about you, but this seems to be a lot of things to do for where we actually want to do very little, because all we want to do is we want to parse these nodes and these ways in our Openstreetmaps file. So there's another way here, and that is we can extend the default handler, and the default handler contains all of these implementations for all of these methods, but the implementations are all empty. We can add exactly those that we want to use. So let's have a look at that. So what do we want to use? Basically exactly what we also saw on the slide. We want to use the start element and end element if the element is away or if it is a node. Let's say those are the two things that we want to read for now. So what we want is start element, and what we want is end element. Okay, we get some default implementations. So let's just look at this, and let's say we just want to react to two elements, and that is a node and a way. And we can do this by looking at the name of the element, and this can, for example, be a node, and this can be a way. We have to do something in each case. And let's say the default is to break. Okay, let's say we want to use these nodes. What we want to reach from a node is we need its ID, because later the array is going to reference the node by saying that's the ID. And we need the geolocation, so we need latitude and longitude here. Okay, so what we want is, we want to encapsulate this node by storing its ID its latitude and its longitude. Okay, the easiest way to do that would be to actually create a new object. So what I want to do here is that I want to read in this information. So let's say there's $double latitude, and the latitude is like the y coordinate and longitude is like the x coordinate. So let's say we want to use parse double, and we are interested in attributes dot get value of let's look at this OSM file of lat and of long and double dot parse double attributes dot get value lat. Okay, and we can also get the ID long dot parse long attributes dot get value, and that was called ID. That's straightforward. Oh, and it's actually a string. Like that. Okay. What we later need when we look at these ways, they have their own ID and they reference all these nodes. So if we look, for example, for this node here, we find it up here. So all we kind of need this mapping, like which node is it. So in here, I actually want to use a map long to, let's say, an OSM node, and that's the ID to node map. Let's say this in new hash map. OSM node, that's something that we don't know of. Let's create this class. That's exactly what so that's longitude and latitude, storing longitude and latitude. I would like to put all of these things into the package BFST18.osm, which is also not present. Okay, but now it's down here, and longitude, and all we want to do here is we want to store long and lat. The constructor should be just say store these data points, and we should have getters and setters for it. Okay, and we can easily do this in IntelliJ by going to the class name. Then I have to press Command and N. So generate, for you it is something else in N probably. And I can say I want to create some getters. I want to create getters for these two variables. Get long, get lat. That's going to be handy in the future. And that's our node. Now we can say, well, we read the longitude, we read the latitude, so now we can say id to node dot put the ID of a new OSM node long lat. What else is there to do for us? So now every time we see a node item in the Openstreetmap file like that, we're going to get the ID, we're going to get latitude and longitude. Whenever we see a way, let's look for a way, like that. Well, there's the start element code. This one is invoked on this way tag. Okay, and all we get here is an ID. What we're interested in is these nodes down here, and later on the tag here. What kind of type is this way? For example, this way is a building. So what we want to do is, when a way starts, we want to collect all of these nodes together and make a path from them. When do we know that we are finished? with a way? Well, when we see this tag down here and this tag down here is going to be going to invoke a call to end element. So in here we want to switch, and when we see a closing way tag, then we know what we want to do is put all nodes found on the way together. Okay, let's also add this default clause. So what we learned from that is when there is a way, we know now there are some nodes to collect. And how do we collect them? Well, we see these ND tags, which is short for node. Or node descriptor, I think. So what we want to actually react on are all of these ND tags. So let's see. What is a way? It's this list of ND tags. So what I am inclined to write is array list or list of OSM nodes way equals new array list. Okay, and this will definitely work, but a list of OSM nodes could be many things, and we'll see many other list of OSM nodes maybe in the future. So this is something more special. It's actually like a OSM way. It's a way in OpenStreetMaps. And I think there's a neat little trick here, and that is that we actually define these ways. Okay, so that we say, well, this here is going to be an OSM way. This is of course not known to us or to Java. So we have to create this class. So let's create it and let's put it again in this package for OpenStreetMaps classes. That. And all we want is that this extends an array list, and in the future this is of OSM nodes. And in the future, this is going to be filled with some additional methods as well. Okay, but I think this is also very nice from a readability point of view, that we see that this is an OSM way instead of a list here. Let's make this actually a field. Oops. A field up here. Sorry for pressing the wrong shortcuts here. Okay, whenever we see a way, we create a new OSM way. Whenever we see a node, we want to add the OSM node to this way. So what we want to do is we want to call way.add, and then we have to present an OSM node to it. We get this node by looking at the reference here. Okay, so this node refers to a node with this ID. That's why we've set up this map over here. So we can see, say, ID to node.get, and then what do we want? We want to look at the attributes of this ND entry, and we want to get the value of whatever is behind this ref. Okay, and this is going to return a string, but we need a long, so I'm going to parse it into a long. Now all the way down here, put all nodes found on the way together. So we have our way, and we want to create a list of lines from that. And a list of lines is actually a path in Java. So there is path 2D. Okay, which represents an arbitrary geometric path. That's exactly what we want. We want to connect all these points together. to create a way like this, to connect all of these nodes together. This is what we're going to use. So we say path 2D, path equals new path 2D, let's say, and we use double as our basic unit. Now, to set up a path, you need to initially move the path to a location, and then you can draw lines on the path. And later on, you can also, so there are two methods on the path that we are going to find useful, and that is move to. Where is it? Move to, and there is line to. So move to just adds a point, and line to connects the last point on the line with a new point. So what we want to do is we want to get the first node on our path, not on our path, on our way, and we want to say that the path move to, and then it's node.get longitude, that's the x value, node.get latitude, that's the y value. Okay, and now from that we want to go through all the remaining nodes on our way, and we want to call path.line2 node.get node.get latitude, but of course our node has to be the ith node on the way. Okay, now I've set up the path, and all I want to do is now add this path to our model. But of course now Java is going to complain, because if you remember, how did we set up last week? Like we wanted to draw some lines. Okay, now I say path, so this actually has to be path. And I think there are a lot of other situations where this now has to be a path. So let's quickly go through them. This remove last, this was only used for drawing. I think it was a useful technique, but let's remove that for now. If you need it later, you have to think about how to include it again. This should be iterator over paths, so this should be iterable, path 2D. Okay, I think in our canvas this line 2D is not going to work, so this also has to be path 2D. This is probably something we need to import as well. Is that it? Okay, doesn't seem to be an error. Let's see what is going to happen. First of all, I would like to see like what's going on in this line. So I'm going to debug before actually, just to make sure that these things are read correctly. So I'm going to set a breakpoint here by clicking on the spot. Then I say run and debug main method. Okay. Oh, and there are a few things in the mouse control. In drawing mode, yeah. Let's say for now we are going to remove this drawing mode. At some point it's going to be handy for you to add it again. For example, if you want to set some custom point of interest on your map, which would be a cool feature in your routing application. Let's go to debug once again. Okay, this works. So let's see, now we are at this breakpoint. There's our way of size 3. Let's go to the debugger. I don't know why I was in the console. Actually, usually this window pops up first. So let's see. So there's our way, and there's our path that we want to create. Let's look at this way. This way consists of 3 OSM nodes. That seems fair enough. Let's just double check with our Openstreetmap file over here. Let's look for the first way. I mean, this should be called on the very first way. So let's just look for this way tag that's over here. And we see a way. We see it consists of 3 nodes. And let's just double check some things here. Unfortunately, we can't see the ID anymore. Yeah, okay, but never mind. Yeah, but we see these coordinates here. We see 3 nodes, and let's just double check here. So the first one should be referenced by this D. Okay, this is actually, here we go. This is the node specification, and this should be the latitude. Yep. And over here is the longitude. Yeah. Okay, that seems fine. Let's go out of debug mode and let's run it for real. Okay. And something happened. Model.add null pointer exception. Okay, so this happened after at the time when we called add here, and this is because when we go we load a file, but we didn't initialize lines here. So let's make this a URL list. And let's give it one more go. Okay, so now we see that we do think that this window is empty. Yeah, but actually, let's look at these latitudes and longitudes here. Latitude, longitude, or especially look at the very top element where there is the bounding box. Like this whole map is between, latitude is y coordinate, so the y coordinate is between 55.66 and 55.68. The longitude is between 12.57 and 12.6, let's say 1. Okay, so those are the x and y coordinates that we find, and this is the actual bounding box. Like those are the maximum coordinates we're going to find. So this means I should go on my screen, and now let's look at this. I should go somewhere up here. Like there's 55 and 12, it's around there. Now if you look really closely on the screen, I hope you can see this. There is actually a black dot here, which is not dirt on my screen. So let's zoom in on that. We see, oh, there's actually something hidden in there. There we go, there we go. So something is there. And I hope you also see, like this is somehow related to things that we see in Copenhagen, I think. Like, let's go back, there's this Stays Kreun over here, and I'm pretty sure that we can see that one over here. But there are 2 issues. Somehow all of this seems to be a bit stretched, and then it's upside down. Yeah, so like, yeah, it's completely upside down, and it's somehow stretched. Let's fix the upside down problem first. So what's the issue here? The issue is that if we look at latitude, if we look at, let's go back here. If we look at latitude, then actually like 0 is here, and then if we go up, it actually increases. What we know from the screen is that up here the y value is 0, and it actually increases in this directory. Yeah, so the map coordinates are increasing in this directory, the screen coordinates are increasing in this directory, so we have to put the map coordinates upside down. We do this by going to our model, and whenever we store something with respect to a latitude, we actually just store the minus value of that. And then larger becomes smaller and everything is fine. Okay, let's give that one a go. But now we have the problem that these values of 55 are actually minus 55, so I do have to scroll up a little bit. Okay, and now I actually see this dot here again. I can zoom into it. Okay, there we go. Yeah, so it still seems a bit, so it seems stretched, but now it's at least not upside down anymore. So let's talk about the stretching. The issue here is that where Denmark is on the Earth with respect to longitude and latitude, at these points, like 1 degree in longitude and 1 degree in latitude, if you think about what's the distance here, they actually differ quite a lot. So just to show you this on Wikipedia, I think it was in this entry. Nope. It was in, maybe it was in this entry over here. Yeah. So if we are at the equator, then what is this? Is this minutes? I think like 1 degree. Yeah, okay. So 1 degree change in latitude corresponds to 110 kilometers and 111 kilometers for longitude if we are on the equator. But now Denmark is somewhere up here at 55 degrees latitude. So there we see that the latitude, like the change in latitude, is corresponds almost to the same distance in kilometers, but there's actually the distance in longitude, like 1 degree change in longitude is then only 55.8 kilometers. So that's why it's stretched. We assume those numbers to be the same, but they really aren't. What do we have to go? We have to go back to our basic math skills, and what we basically want to do, and I open this Wikipedia page here, is let's assume like the Earth is this ball, well this here is the circle. So at the equator, like we're up here, Denmark, 55 degrees, that's probably up here. What we see is like the x-coordinate. Yeah, it's not 1 up here, but it's rather like whatever this projection down to the x-coordinate would be. Yeah, and as you know, like if the latitude, that's the angle here, this is phi, then the cosine of phi gives us this factor down here. What would be the x value if it's normalized to 1? So that's what we want to find out. And of course, these the unit here of the cosine, that's radians, that's not degrees. So but on the other hand, latitude is given in degrees. Okay, what do we have to do? So we have to scale each of the longitude values by the cosine. How do we find out what the scaling vector should be? Well, these OSM files, they actually come. They have this line called bounds, where we get like the minimum and maximum latitude and minimum and maximum longitude, respectively. So let's read them out, and let's compute this factor from that. So let's go back to our model, and now the name of this tag we are looking for is called bounds. Okay, and now what we want to do is we want to read out all these values. So min latitude equals double.parse double attributes.get value of the element called min lat. Like this. Let's double check. Min lat equals, okay, this should work. The same has to be done for the same has to be done for minimum longitude, maximum latitude, maximum longitude, and we have to change this respectively. So this should be min long, this should be max lat, this should be max long. Okay, and this is important to know for the view as well, these values. So I want those to be members of the model. And I don't know if I create a field here. Perfect. then I can actually say I want to do this in the model. But and so on. So min long, min max, long. And I also want to create getters and setters, so I go to the class name again, Command N, create some getters for those. Okay, cool. Let's continue here. So what am I now interested in? I'm interested in the average latitude. So what's the y value? The average y value. Double average latitude equals, I take the min latitude, take the difference between max and min, divided by 2, that gives me the average latitude. And now to compute this factor over here, yeah, I have to convert the latitude, the average latitude, into radians, and then have to compute the cosine from that. So either you still know how to convert from degrees to radians, or you ask how to convert from degree to radian. And what does it tell you? It tells you you take your degrees, you divide by 180, and you multiply with pi. And if you think about geometrically, this also makes a lot of sense. What do I want to do? I want to take the cosine of the average latitude divided by 180 pi. Okay, and now I have to take all of my longitude values, and have to multiply them by this factor. So in particular, my min long has to be multiplied with this factor. My max long has to be multiplied with this factor as well. Then I still know, like, my latitudes, they should be upside down. So max lat equals minus max lat, min lat equals minus min lat. Okay, and also what I need to write here is, actually here I also need to multiply this factor. Okay, so this should be a field of our OSM handler. Let's have a look. Nothing works. Perfect. Double dot parse double. So what were this? Didn't. Okay, yeah. This shouldn't have worked. And now I also see, like, there's a break missing down here. So we would have got another error. Okay, let's have a look. Let's scroll a little bit up. There we go. I see the point. I hope you see it too. Let's move into that a little bit. Perfect. Yeah, now it actually looks a lot like that. Okay, this part over here, this part over here, they kind of look alike. That was the first step. So now we took all of our ways and we just drew them. Like, no matter which type of way that was. But let's commit something from this here, because we already got pretty far. Let's look at our status. So we have to add our OSM way and commit draw all ways in an OSM file. Okay. And I actually all files. OSM. Or it's actually paths in an OSM file. Okay, perfect. Next step. Now, what we actually know is that all of these ways here have a different meaning. So there's, for example, let's look at two of them. Let's look, for example, this O2. New road here. Is this somewhere? So there is coastline to the primary road, Christiansbrücke. Yeah, let's look for that. This is a way, Christiansbrücke. You actually see like this is a highway, the type is primary. And if we click on this primary, it should bring us to an overview of what that means. So highway primary, and that means this is a highway that links large towns. And this is actually, and you should, for example, compare that to a one of the others. There was this Slottsholm scale over here. This is a residential road. If you click there, road in a residential area. Belongs to a highway. If you click actually on highway, then you see all of the different values this could have. So there could be motorway, trunk, primary, secondary, tertiary, and so on. Okay, so there are many different ways. Also here you see some rendering hits. So this is how they are rendered in OpenStreetMaps. So this is something we could look out for. But there are other things. For example, there is not only, let's go back here to our actual map. There are not only streets, but there are buildings like Börsen over here. That's a historic building, and this has some other tags over here. In particular, this has the tag building to say, well, this is not this here is of type building. Let's look into something else. Let's look, what is this type of water here? Oh no, let's look for another type of water. I'm a bit unsure whether this is actually on our map. Let's look back here again. So this is a water, and you can see here this is a way, and it has the tag natural and it's of type water. Okay, this would be something that we would draw differently as well. So what we see from this discussion, or what I want to make clear here, is that there are ways, but a way has many different meanings. So we have to check like what kind of way is that to render this appropriately. Let's have a look. First of all, we see that we won't get very long with this list here of lines, which is oddly named anyways at the current moment. Yeah, so there are actually many different types, and each type should be rendered differently. So now we should think about like how to restructure, how to make our code very generic, to add support for all of these different kinds of structures that we find in the OpenStreetMaps file. And so the most generic data type here, so there's path2D, yeah, and this one implements shape, and this is the important thing. So a shape is a geometric, or yeah, a geometric object is that we can draw. That is a shape. So actually here it would be much more appropriate to call this one a shape. Okay, but then we would have the problem that, so for example, because this is the most generic type, so this works immediately, this won't work, because this should be a list of shapes. So, but now we want to map like different types of shapes, or different types of like buildings or different types of ways that we find in our OpenStreetMaps database to a list of shapes. So now actually what we actually want to use is a map from something like a OSM weight type to a list of shapes. Well, let's see, let's call this shapes. Yeah, so what I would like to do is something like that. Like I would map from a weight type that I know of to a list of objects that belong to this weight type. So this weight type is actually should not be a class, but rather it should rather be an enumeration in Java. So there has a certain type we can specify. So, and also IntelliJ, because I call it type, IntelliJ suggests that it should be an enumeration. Let's create this enumeration and let's create it in our OpenStreetMap package. There we go. And all we currently know of is, I'd say, we know of the type unknown. That's all we know. Okay, now this works. The OSM weight type. But then, and that's just something that you might have seen if we look at map, the map documentation. There is actually a map that is in particular useful if you have enumerations, and that's called a enumeration map. Yeah, a specialized map implementation for use with enum type keys. That's exactly what we want to use. So let's call it like this. And then I want to initialize my map at the very beginning. So let's create this method, public, or private, void initialize map. And what I want to do is I want to go through, no, not void, rather enum map. OSM weight type list shape. Okay, so let's initialize one such map. For OSM weight type. Yeah, okay. It's new enum map. And here you actually have to specify, so cannot resolve. There is no constructor for this type. You have to give it this class object here. And we go through all the values. For example, this is currently only unknown, but then we say map.put type new array list of shapes. Return map. Okay, now we have to generalize our model a little bit. So now this is the basic data structure here. So we also have to, instead of adding a line, what we want to do is we want to add something that has a certain type. And that is a shape. And what we want to do is we want to call shapes.getType.add shape here. This one is okay. Read from OSM is okay. We see the save function doesn't make a lot of sense because here we wrote lines, but we actually want to shapes as well. What we should now fix is that here we have these doubles that we didn't save. So let's save them as well. Write object min longitude, min latitude, x longitude, latitude, like that. And when we read all these files, say something. So we don't want to write, but we want to read. Yeah. And OS is going to be input stream. What? Okay, this was actually not the smartest idea to copy and paste that. Okay, so the first object is shapes. So this is shapes, and we have to give the type here. So this is it. And this is not going to suffice. Is this? No, this was wrong. Okay, I think there is a pretty much better way of doing this that I'm currently unaware of. So then there's, now we should double check, like there is min long equals double. The next one is min net equals double. So you have to read them exactly in the same order. So max long equals double. There's max net equals double. Okay, this is saving and loading. Now the iterator here won't work because this is actually, so this is an iterator over shapes. But what we need to know is like what type do you want to iterate over. And this would change the iterator. So this is different from what we wrote here. So we now are now going to do is we're going to remove that. And we are going to call this get. It's not an iterator anymore. And we say shapes dot get type. Like that. And in here, for example, we would say model.get OSM type unknown. Okay, it's going to complain because for each not applicable to type Java iterator. So this doesn't work because this should be iterable. And then this is not an iterator, but rather that itself. Okay, this is not a path, this is a shape. Let's look at all the other problems that we ran into. Yeah, add here, there's the path. And so here we also need to set up the type. The type should be a field in the OSM handler. And where do we get the type from? Well, we get the type from our way in certain different ways. Let's say for now the type is always unknown. Okay. So this was some work I wanted to do to make the next steps easier. So now we have this map that maps types to a list of shapes. And the only type we currently know of is type unknown, so we don't know how to render this correctly, but now we can add one type after the other. Let's run it again, just to make sure that it works. Okay, so there's still, okay, so this still seems okay. Perfect. Let's fix this zooming in, zooming out problem, because now we actually, when we have access to min lat and min longitude, we also know like where should we put our center of the map. So here in the main window, what we actually want to do is that the canvas here, put canvas to correct, or put screen to correct place on canvas. Yeah. So we want to pan and we want to zoom in all of the things that I just did manually. So what I would like to do is I would like to say first pan to, and now I need access to the model, because now I want to call model.get latitude and get longitude. So, but here I currently don't have access to this model, so let me just give the mainframe access to this model. And we have to, so in here the main view should also get the model now. Model, like that. So now I can say, well, I need to go to latitude and latitude, max latitude. So this places the corner of the screen correctly to the upper left, and now I have to zoom in. And how far do I have to zoom in? Like, I want to zoom into this upper left corner this time, but how far do I want to zoom in? Well, I want to look at the width of my main window, and now I know I want to zoom in as far such that I exactly get the one of the dimensions, either latitude or longitude, completely on the screen. And I can do this by dividing the width by the difference of, let's say I go latitude between maximum and minimum. So this gives the correct, should give the correct scale value. Let's see if this works. Nah. Where are we here? Okay, now we are somewhere down there. Ah, okay. Yeah. Almost. Okay, now everything is upside down again. What? Just a second. Okay, what is happening? Why is everything upside down again? Ah, because this was a negative number. Okay, yeah. Okay, but now we are actually incorrect here. I'm always getting confused here. Yeah, it's a bit more trial and error. There we go. There we go. Now we are correctly zoomed in at a decent spot. Perfect. Now let's add some logic to that. And let's say, so I'm going to add a few parts here, and the rest is something that you can do at home. So let's first say I want to draw certain ways different than others. For example, let's say I want to add the type road. Oh no, I can show you a different way of setting these things up. Let's look at my, I want to look at my model. I'm now in a way, And what I want to know of this way, let me just check that. What I want to know of this way is, for example, so we had this O2, this was a primary. So the tag that comes with our way is highway, and the value then is primary. So for this way, we have to get the tag. If it's highway, we know that's a road, and if it's primary, we know that's a very important road. Okay, so how are we going to do this? Yeah. So we check for whenever we see a tag here. Okay, and we switch. We switch for the name that we see there. Let's just check. Like, is there a key called highway? And then the question is like, what kind of value do we have here? Okay. So there is this tag here, and I can ask like, or I can switch by attributes dot get value of k. If it's highway, then we actually know like this is a road, so we set type equals OSM way type dot road, and that's what I want to write. A road is not possible, but I can just create this iteration constant inside here. I don't actually have to leave the model. That's nice. So you would rather think like, oh, I go back and forth between all of these things, but it's much easier to just stay in this model. And let's say if attributes dot get value here, equals primary, then we actually know much more. Then this is let's say this is a highway. Okay, and for all the other ones, let's say make default clause, we'll just break. For example, this is for highways. Let's go to my canvas, and for example, so I can say all the unknown things, well, this is, we just draw them here. Let's say, for example, let's make other roads a bit bigger. So I go through shape, shape model.get OSM way type, and now all the rows. Now I can actually call this roads, and a single one is a road. And let's say let's set a color here as well. Yeah, the nice thing in IntelliJ is that you can actually click here to choose a nice color. Let's say normal streets, they have this color here. No, let's say they have this color. And let's say if it is a highway, it should be even thicker. And then call this highway. And I think let's make this color right. See if something has happened. But maybe let's reconsider what happened. So I did a lot of work for the at the very beginning. To refactor, but now it's pretty easy for me to specify and iterate over newly built types. Okay, and as you will see, like to get a good rendering of something like that, then you just have to react on many different building types and give them all a specific color and shape and fill. Let's see what has happened here. This didn't work out. Let's see where the problem lies. Okay, I forgot a break statement in here. Yeah, so this is now a bit odd because we have this large switch here and then there is another switch. Cool. So we see like 10 times basic color is far too. Okay, we see what do we see here? Like this is not very thick at all. These are not very thick at all. So let's make them a bit thicker. Canvas view. Okay. Yeah, because of all of these coordinates, they are so tiny. It's a bit. Let's start with this. 0.00, let's say 5. Okay, this is. I mean, nah. I'd say this is a bit thick now. Let's add another 0 here. Yeah, better. Let's change the color here to make it a bit better visibly. Maybe like that. That's really difficult to see. Let's get some inspiration here. Oh, they are. Yeah, but for us, many things are currently white, so I don't want to do that. Okay, let's go. Let's take this color. Yeah, you can improve on that if you don't like these colors. Yeah, we see it's still a bit thin, but it's clearly visible. So like you have this is the O2. This is the only street apparently in this little drawing that I had, which has the which has this type over here. Yeah. But we see that it somehow works. Now we could actually add, like, there are these footpaths over here, and you could have a look at how to do that as well, and how to add a dashed line. You will find something on Google, how to add dashed lines and, for example, set up these footpaths. Let's go to something else. Let's go maybe to this water complex one more time. So this is, so we see that it's water because it has this flag natural equals water. We can also click natural here to see all of the different types. So there's wood and tree, and yeah, there is a body of water such as a lake or a pond. Okay, so let's also look for this. So if the tag is natural, Then I want to know, is the value associated with this equals water. And then what I want to do is I want to set the type to water. And I create the constant in here automatically. Okay, if it's water, then what I want to do is then I want to pick a very nice blue, like that. And then there are two different things here. So we draw it. We can also fill it. So with fill we actually add the color to it. You see it now down here. Whereas if we say draw, then this fill is missing. Okay, then it would just look like this. But now we want to fill it. Okay, and we do see that there is actually, so in here we see some water, and there we see water. Let's move out a little bit. We see here this river, this part here, which starts at KU and ITU is somewhere over here. Like this canal is also here. But we do see that a few things are missing, and those things are going to be a bit tricky. So one of them is going to be quite easy, something else is going to be quite tricky, and we're going to do it next week. And this is here, like this whole channel that splits, like inner Copenhagen from Christianshavn or Amager. There is no blue here. And this is actually also pretty tricky. And this will need a lot of explanation from my side. So for example, so what was not there is, for example, this part here. Like no one said, like Christianshavn Canal. This is not in any sense blue here. And why is that? Because if you ask for what is here, it says there is this recycling point, node 333, artwork, residential roadway, building, coastline. But as you can see, there is no water here. That is because this part here is water because there is a coastline. And the coastline is this whole part here. And the coastline says everything in this area, this is non-water, but everything on the opposite side, this is water. And there is another coastline. No, I don't know if this was, yeah. There are other coastlines, for example, this one. Yeah, and this one defines a new barrier between land and water. So this is water because it's within these coastlines, or outside of the coastline of Denmark. Actually, and this makes Copenhagen actually very difficult to render in the first place, because a lot of these bodies here of water are defined by coastlines, but not by this water element. So this is also why it says like natural water. The tag that we used, what we used over here, this is like a lake, but it's not the sea. And we're going to take this into account next week. But something else is strange, and that is like this body of water here. Like, okay, and I forgot to tell you, like these purple lines, they make up the coastline. But here, this part, this is actually not part of a coastline, so it should be drawn blue for us. So let's look at that one. And it says this is a water. If we click on it, it doesn't say way, but it rather says a relation. That's a relation. Yeah. So this is not a So this is not a way, but it's rather a relation where this way here is the outer barrier, and this way in here is the inner part. So they are not only ways, but they are also relations. And the relation consists of ways. Okay, so this relation stays consists of two ways. So that's something we have to set up. So there could also be a relation in here. Then we would have to say, well, we have to create a new relation. And I would say, let's call this an OSM relation. What is an OSM relation? That's a class to specify a collection of OSM ways. Let's put this into the OSM model. Package. This extends an array list of OSM ways. OSM way. Okay, and let's include important class here, just in the way that an OSM way extends the array list of OSM nodes. Okay, this relation as the way up here should be a field of our OSM handler. Okay. So let's look at a relation. Okay, so there is a relation. It has a member type way, a reference to the way, and a role that this way plays. Okay, so and this reference here, it references a, as name says, a way. Okay, so that's what we have to do. Okay, let's double check again. So, and the relation has a member. That's what we have to look for in our parsing. So when we say a member, then we want to add something to our relation. We want to say relation.add a OSM way. And how do we get the OSM way? Well, I think we have to store that one as well. So this is, we need a map to store relation from an ID to an OSM way, it to way. When we know, like, where do we see it? There is this way here. We can put it into way.put new OSM way. There is already. So we want to put the way there, and the ID is. Let's look at our way one more time. Let's look at a way one more time. Okay, it also has an ID. So we look at the attributes dot get value of ID. Okay, and of course we have to pass that into a long from this string. Okay, so now we also put the way, and you see like there's a it says new OSM way. We put this new OSM way in here, but because it's a reference, like all of these later additions to the way down here, this is also going to be reflected in the hash map. So this is easy to do, but you might question like why is this possible? It's possible because this is a reference to way. If way is changed, then this is reflected in this mapping here as well. Okay, now we want to go to the relation. If we see a member, and we want to add the way that is behind the, what was it called? I think it was called reference. So there's member, yeah, reference. Get long dot parse long and attributes dot get value ref. Okay, so this is the relation and member. Of course, at the very end, when we close our relation, down here, what we have to do is we have to set up these ways together. And now a path is a very generic path. So it allows to do many things. Oh, this one open as well. So let's go to our model, and down here we now have to do something when the relation is closed, and we want to create a path. Okay, what? This is not possible. I can also do this up here. Fair enough. Okay, what do I want to do now? So now I want to go through all these ways that are stored in the relation and add them one after the other to our path. So I want to go through OSM way in our relation. And what I want to do is I want to take my path. I want to move to node dot get long node dot get latitude. Of course, the node is let's put this one up here as well. Node equals rate of get 0. To move that one, and then I want to go for all the other ones. I'm actually copy and pasting this. As a disclaimer, some parts here have to be changed. So now they look very, very similar, but that's actually because a few strange things are going to happen here. We won't fix them in this screencast, but we are going to talk about it next week. Okay, but now for a relation, I go through all of these relations. I get a first node, move my path towards it, and then I draw a lot of lines. And for the next way in the relation, I do the very same thing. Yeah, but so I first move my path to something else and then draw all these lines. So that's how I actually build a polygon, and not only the single line shape. Okay, at the very end, I add my path here as well. Let's see what happens. Okay, as always, read from OSM, null point exception in here. So the way that we define here, that is, this could actually, let's check something. If node equals null, way equals null. Maybe this, okay. Let's just check something. So there's ID to way. We put our way in there with its ID. If we see a member, we look at the ref. And that was correct. We look at the ref, and that should reference an array. Oops, let's go back to the model. So this should work. Oh, this, before I forget it, this should be also unknown here at this point in time when we open the relation. And this seems fine. Let's let's do it like this. W equals ditch. And we want to add W if W is not equal to. Else, and I want to know when is this null. That's why I put this breakpoint here. And I put this semicolon because it should be that it is like a statement in there. There is a statement. Let's see. Okay, this is strange. Okay, so long story short, a semicolon, like I tried it, like I did here, does actually not work. So yeah, you should provide a comment. Let's something like that, and let's set a breakpoint, and now let's start the debugger one more time. Yeah. And now we actually see that we are in this null phase over here. So let's see if that's a problem that we did, or if this is a problem within the data file, our OSM file. So what we have here is that we have this null call, and we can actually check like what was the reference here. Let's take a look. We go to attributes, and we have to find, so this is called type, this is called ref, and that's the value. So that's what we're interested in. Let's go to our OSM file and search for. Okay, so this node is referred over here. Yeah, but that's it. So this node is referenced here, but it's actually not a node in our data set, or it's not a way in our data set. This way actually doesn't exist. So it's actually fair enough to say that some of these ways that could be a part of a relation are null. So let's keep this null check in here. And let's give it one more run to see how far we got. Okay, and what we can see here is a lot more blue. For example, now the second part here is blue. And I hope you recall the second part was this relation where there is a way here specifying basically the waterline, and this way here, Kenin Öen, which is this little island down here. So now we can also draw those correctly. Maybe as a last part, let's draw something else. Let's look at these buildings here. Let's take this building. Let's check it out. So we have all these nodes, trees, building. Okay. So as you can see, there are actually three buildings, different buildings here. A tiny building. Let's check out this large building. And this large building is a way over here, and it has the tag building. So let's look for this tag as well. I hope we can see that some of these buildings, they should be a little more complex. Let's check, for example, this building out. No, this is not going to be more complex. No, 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 this is, those are not as complex as I hoped they would be. Okay, all of them are different as well. Maybe let's check out, for example, let's check out this one. It's the library. We can see this building is actually pretty difficult. And here we can see as well, this is actually a relation. And it consists of different rays. It's exactly like a body of water contained different rays. So actually we should be able to draw these as well. Let's give it a go. So what we need to check as well is if there is a tag called building. So let's say case building type equals OSM type dot building, and let's create this enumeration constant. And let's break. This should be all we need to do. So now it also sets the correct type for buildings. So we go to our canvas view and let's draw some buildings. Oh. No, I'm gonna do building. And let's pick some grayish color for a building. Maybe like that. Let's give it another run. Let's see if something has happened. What? Okay, now all of my... So we see that it worked for most of the things correctly. So down here we see all these buildings, but a few places here are just also connected. So this area looks nice, all these buildings look very nice, but then all of the water areas became buildings as well. Let's check that out. Yeah, okay, we can see this happening over here by missing this break statement. That's really the problem with these nested switch statements. Perfect. Much, much better. Here we can actually see the, I think that's the library. We can also see there are a lot of issues with the painting with regard to some bodies of water. And let's just let water be placed first. Okay. That's much better. Okay. So now we can nicely see some buildings. We see a few spots of water, but we also see like these lakes. They work. All these lakes area, or this little fountain down here, that works perfectly nice. But there are a few lakes that don't work. Okay, especially this canal here doesn't work. So there are a few things that are now incorrectly working. There are many things you could do here to get this done, and I think you should give it a try. Actually, the easiest way to fix it on the current level would be to draw everything in blue. and then just place all the land body on top of that. So also all of these things here, that's actually some land area, and you could just draw something in green there after finding out which type of way such a land area is. Okay, you also see like these bridges, they look a bit odd. You could also fix that. But I think we got pretty close, and I hope you got the idea of what's going on. Here. Okay, let's compare it to where I think you could go. And of course, this is pretty far, I think. So especially because of here, you actually need to display C correctly. If you want to have a challenge, what you need to do to draw these areas correctly is that you work with coastlines. So if you go to relations, and for example, if you check this one out here, then there is a okay, it didn't show me that here. Let's go over here. And there is always here. And there is always a coastline. And these coastlines are normal ways. But what you have to do is you have to combine all of these coastlines together to fill up the whole area. And from that, you can actually draw, you would be able to draw these areas of water here correctly as well. Okay, but I think that's it for now. So now you can go ahead, you can look at all the other features, look at what kind of type these ways have, and then you can customize these drawing mechanisms. Maybe it's a good idea to make this a little bit generic. You see here there's a lot of code duplication, and it might be useful to just do this in a bit more generic way. So storing with a certain kind of OSM way type, also maybe its color, the stroke width, and other things. Yeah, but I hope you enjoyed the screencast. I hope you agree that we got pretty far, and I hope you have fun extending this basic prototype. Thanks for watching.